The natural base e. The natural base e is a number that was found by Leonhard Euler. It approximates to 2.71828 and on forever and ever. So it's kind of like pi, how it is a irrational number. We use this a lot for compound interest formulas, y equals p e to the RT. And this is any time that we have a problem that talks about interest being compounded continuously. This is a picture here of Mr. Euler. Just thought it was a very interesting picture and something we should include in the notes. We're going to start off by using our calculators to approximate values using base e. So on your calculator, find out where your e button is. A lot of times it's going to be like e with an exponent. Usually e buttons always open up an exponent for you to add something into. So for this first one, click your e button and type in negative 0.75, and let's round to 3 decimal places. I get 0.472. If you're not getting that, or if you can't find that e button on your calculator, make sure you pause your video and ask your teacher. In the next example, we have e to the negative x, and in for x, we're going to plug in negative 5. So that's going to look like e to the negative 5, or you can make that a positive 5. And we get approximately 148.413. And for the last one, we have e to the negative 2x, and in for x, we're going to plug in 1/4. If you don't want to type that fraction into your calculator, you could use 0.25. And we get 0.607. Example 4, you deposit $4,650 into an account that earns 5% annual interest compounded continuously. Find the balance after 10 years. So the big thing that we're looking for here are the words compounded continuously. If it had said compounded monthly or daily or quarterly, then we would be using our other investment equation that has the n for number of times compounded. But in this case, since it says compounded continuously, we're going to use, I like to call it PERT, P-E to the RT. So first, we're going to plug in values for P, R, and T, excuse me. P is our starting amount, so that's going to be 4,650. E is just a number that we're going to use in our calculator, so leave E as E. R is the rate, 5%. We're going to change that to 0.05. And our time is 10 years. We can plug that whole thing into our calculator all at once, and we get a final answer of $7,666.55. Tritium decays over time. In a sample of tritium, the amount Y remaining after T years is given by this equation. How much tritium is left after 9 years? So we want to know how much is left. We're solving for Y, and we know our T, time, which is 9 years. So let's plug 9 into the equation, and then we can just type this whole thing in our calculator to find out how much is left after 9 years. So we've got 6.03 milligrams. Okay, now I want you to pause your video and try these independent practice problems on your own, and then restart your video and I will work through them with you. For the first problem, if you got your answer in scientific notation and you don't know how to convert it to decimal form, just pause your video and ask your teacher about that. If there are any of these that you're confused on, please make sure to also ask your teacher about that as well.